Namaste viewers, I am Rekha Rao from India, a researcher in ancient history and archaeology. Welcome to the course on the fundamentals of Indian temple architecture. This is topic 5 of an 8-part series. In this topic, we will discuss golden ratios in temple sculptures. In ancient and medieval periods of India, the study of mathematics was a preoccupation of sculptors and builders all over the country. Mathematics and geometry were a specialized discipline of knowledge that was widely adopted in temple structure and sculptures. The extensive usage of golden ratios is an example of the sophisticated knowledge possessed by Indian temple builders. Firstly, we will explore the definition of golden ratios. We will then look at the example of how golden ratios were used in the structural aspect of a temple. We will also study 2 examples of the usage of golden ratios in divine sculptures in both standing and sitting postures from different temples and different periods. We move to slide 1. Let us start with the definition of golden ratios. Golden ratio is a special irrational number, 1.6. In geometrical terms, the golden ratio is observed when a line segment is cut into 2 pieces and the ratio of the longer part to the smaller part is 1.6. Let's proceed to slide 2. Golden ratios are also observed in other geometrical forms such as rectangles and triangles. A golden rectangle has the dimension of the length and breadth in golden ratio. Similarly, in a golden isosceles triangle, the hypotenuse and the base length are in golden ratio of 1.6. When 2 equilateral triangles are interlaced and inscribed in a circle, similar to the construction of Star of David, it forms a diagram called Shatkona Mandala in Sanskrit. All intersecting points on the sides of the equilateral triangles are in perfect golden ratio. This process results in 6 smaller triangles as shown in the bottom figure of slide 2. This is considered as sacred geometry in Hinduism. Before studying the examples of golden ratios in Indian temples, let's first look at the interesting history behind golden ratios. An ancient Indian mathematician called Acharya Pingala from 2nd century BCE discovered a never-ending sequence of numbers in the form of 1, 2, 3, 5, 8, 30, 21, 34, 55, and so on. He called the sequence Matrumeru. In the sequence, each number is the sum of the preceding 2 numbers. For example, 8 plus 13 gives 21, and 13 plus 21 gives 34. In this sequence, the ratio of any 2 numbers is a constant of 1.6, which is the golden ratio. This sequence, discovered by Acharya Pingala, was popularized 14 centuries later by an Italian mathematician called Fibonacci in 1225 CE. The sequence was called Deva Pramana in Sanskrit. Deva Pramana means divine proportions. It was called so because the sequence of numbers was observed in nature, like the branching of trees, arrangement of leaves, flower patterns, pine cones, seashells, etc. Let's now look at slide 3, an example of how this ratio was used in the structure of a temple. Golden ratios were used in computing the distances and heights of the geometric structure of a temple, such as the towering roof, pillars, and panels. Slide 3 is a panel from the ceiling of Halebidu temple of 12th century CE in South India. This panel is a rectangular mandala consisting of 9 panels of various size and multiple figures. Let's focus on the bottom right frame of this mandala. The zoomed image is on the right side of the slide. The outer part of the frame has lotus flower-like design, which indicates the unit of measurement. The length of the rectangle has 5 flowers and the width shows 3 flowers. It is interesting to note that the ratio 5:3 is 1.6, which is a golden ratio. The method of adopting golden ratios in golden rectangles to create figures with perfect proportion has been demonstrated in this mandala. The golden rectangles were used as a guide chart for artists and sculptors in creating structural aspects of panels. It is also a demonstration of how to design multiple figures in one frame with perfection in proportions. Let's now study slide 4, how golden rectangles and subdivisions were used to carve temple figures. The left-hand side of the slide 4 illustrates the construction and subdivision of a golden rectangle. When a golden rectangle is segmented into a square, it results in smaller golden rectangles. This process of subdivision continues endlessly. The right-hand side of the slide 4 illustrates a panel of the mandala. In this panel, the outer boundary A, B, C, D is a golden rectangle. When this rectangle is cut into a square A, E, F, D, it results in another golden rectangle E, B, C, F. As illustrated in the panel, this process can be continued to result in other golden rectangles G, H, F, C, and so on. Temple sculptors relied on these golden rectangles to achieve pleasing and proportionate physical structure for temple figurines and sculptures. By leveraging golden ratios, it was possible for the sculptors to create infinitely large and infinitely small patterns, observing the same ratio of the original pattern without any deformity. For example, the figurine GHFC is proportionately sculpted such that key anatomical parts appear at the precise location of golden rectangles. The navel region, the knee, the length of the legs in sitting posture all appear at the intersecting lines of the golden rectangle. Let's now study in slide 5 how golden equilateral triangles were used in the construction of divine figures. The left-hand side of the slide illustrates the construction of golden equilateral triangles that are inscribed in a circle. For example, the intersecting points on the right side of equilateral triangle DFB and EAC are in perfect golden ratios. The image on the right-hand side is that of Nataraja, the Lord of Dancing. This masterpiece statue in bronze is from Chidambaram Temple of South India from 12th century CE. The figure is inscribed in a circular frame with fire motifs on the outer range. He stands on a dwarf demon below his right foot. When we superimpose the plan diagram on the left side to the slide, to the side of the slide on top of the figure of the deity, we find that the intersecting points of the equilateral triangles lie exactly on the top of key anatomical parts. For example, the central point S corresponds to the navel of the divine figure. The bended knee, the length of the hand, the length of thigh, foot, face, etc. all fall in proportion to the golden ratio defined by the intersecting equilateral triangles. The pleasing proportions and the beautiful posture of this divine figure of Nataraja matches perfectly with the golden ratios. This proves that ancient sculptors of India had the knowledge of golden ratios, which was documented in a treatise called Shilpa Shastra. The concepts and principles of Shilpa Shastra were fundamental to design temple sculptures. Let's now study slide 6, another example of how golden isosceles triangles were used in divine figures. The left-hand figure of slide 6 is a plan diagram illustrating how a golden isosceles triangle is constructed. In this isosceles triangle, the ratio of the hypotenuse ET and the base lengths PT are in golden ratio. The big golden triangle EPT can be cut into sections, resulting in smaller golden triangles. Each smaller triangle observes golden ratio similar to the big triangle. The image on the right-hand side of the slide is that of Buddha. This statue is from Saranath Temple of North India, where Buddha delivered his first sermon. The figure belongs to 5th or 6th century CE. The Buddha is in a sitting posture called Padmasana, and his hands are held in Dharmachakra Mudra. The head is surrounded by a big halo. Once again, when we superimpose the plan diagram on the left side of the slide, on top of the Buddha figure, we find that the intersecting points of the golden isosceles triangle lie exactly on top of key anatomical parts. The point D corresponds to the navel of Buddha figure, the bend at the knee, the bend of the elbow, the length of the hand, foot, face, nose tip, throat, all fall in proportion to the golden ratios defined by the intersecting isosceles triangles. The pleasing proportions of this Buddha are a direct result of utilizing golden ratios. This depiction of Buddha is widely considered to be one of the most graceful and peaceful figures of Buddhism. Let's now summarize the key learnings from this topic. The extensive usage of golden ratio in Indian temple structures and sculptures demonstrates the sophisticated knowledge possessed by Indian temple builders. Mathematics and geometry were a specialized discipline of knowledge that was widely adopted in temple structure and sculptures. The golden ratios derived from an endless sequence was discovered and used by Indian temple sculptors nearly 14 centuries before being popularized by the Italian mathematician Fibonacci. The usage of golden ratios brought about standardization so that sculptures of any size could be created with perfect proportions. Thank you. I look forward to seeing you in the next topic.